So just going to take a quick look at the map that you use to solve the stoichiometry problems, because depending on the type of problem, what the question is asking for, and what you're given, there are different ways to apply the map, or sort of different versions or variations of how to use the map. So I just wanted to quickly run through all the different possibilities that you might encounter and how you would adjust the map, or what you put into the numbers that you put into the map accordingly. So there's different units that you could be given, there's different units you could be asked for, or any combination. There's moles, there's energy in kilojoules or mass in grams, there's particles like atoms or molecules, there's volume in liters of a gas, and then there's also questions involving density of liquids and solids, and then trying to find the volume of liquids or solids. So if you're starting with moles, and you're looking at the boxes here that are on the stoichiometry map, when you're given moles, you can start in the second box because that's where the moles go. You don't need to do the first box because you've already got that step done when you're given moles. So you just put the moles given in that box. And then you go to the mole ratio, and all the numbers from the mole ratio always come from the equation itself. On the top would be the coefficient of the unknown, what you're trying to find. And on the bottom goes the coefficient from the equation of the known, which would be what you were given over here. When you multiply the moles given times the mole ratio, you get the moles of unknown. And if that's what you're being asked to find, then that's where you can stop. You don't need the last two boxes if you're trying to find moles. If you do, we'll get into how you get to the other boxes in the next few slides. If you're dealing with energy, you can also skip this first box because there is no conversion from grams or anything to moles when you're dealing with energy. You actually start in the second box here. You just put in the number of kilojoules given into that box. And then the difference here is that in this middle box with the mole ratio, since your known is kilojoules, you're going to put the number of kilojoules from the equation and just take the number. Let's say it was 1,000 kilojoules in the equation. You would just put that number right in here. This would be the equivalent of the coefficient from any other thing that's in the equation. If you're being asked to find energy, you actually will stop here too. This answer will be in kilojoules if you're starting, if you've got kilojoules on the top. And then if you are given mass, this is sort of the standard long type of stoichiometry problem, you're in the first box. The first box is used to convert from other units into moles. You always have to get to moles unless you're doing energy. So you put the grams that you're given in the problem of your known substance, and then on the bottom goes the molar mass, which you find by looking up the mass of everything in that compound on the periodic table, adding it together, multiplying any element times any little subscripts it has, like H2O, you have to multiply the hydrogen times 2. And then if you're trying to find the mass, you need to have the molar mass of the unknown into this next to last box, and then you would multiply this, which is the moles, times the molar mass of the unknown, and that gives you the grams or the mass of the unknown at the end. Now if you're given particles, which could be atoms or molecules, you are going in the first box because we have to convert particles to moles, and we do that by putting the number of particles given on the top, divide it by 6.02 times 10 to the 23rd on the bottom. That's the number of particles in a mole, whether it's atoms or molecules, and that gives you the moles here, and then you go through the mole ratio and you get moles here. And then if you're trying to find the number of particles, you multiply the number of moles of your unknown times 6.02 times 10 to the 23rd. So if you're starting and ending with particles, then these two boxes here and here are both going to be 6.02 times 10 to the 23rd. Volume of a gas. This is another one where, like moles, we have a constant value that we're going to use. We're going to start in the same box at the beginning because we have to convert volume. If you're given liters, you have to convert that to moles. Put the liters given, the volume, on the top, and you put 22.4 on the bottom. That's called the molar volume of any gas at STP, or standard temperature and pressure. For right now, you can always assume it's standard temperature and pressure. It should say that, but if it doesn't, just assume standard temperature and pressure. So you're going to use the 22.4 there. And then if you're trying to find the liters of gas, you put 22.4 in this box over here, where you would put 6.02 times 10 to the 23rd for a particles problem, or the molar mass of the unknown for a mass problem. Now when you've got density, you have to do a different step before or after all these other boxes that we've been looking at. So this is kind of a little bit outside the map. You have to remember that density is equal to mass divided by volume, which we write sometimes as D equals M over V. So depending on what you're trying to do, there's basically two variations of this formula. If you want the mass, mass is equal to density times volume, M equals D times V. So if the answer you want is the number of, if you're given the volume and you're given the density, you would convert the volume into mass by multiplying by the density. That gives you the mass, and then you would put that mass into that first box of the stoichiometry map, and then continue from there like any other mass problem. Now, if you're trying to find the volume of a solid or a liquid, at the end, what you do is you take the mass, which you would get in that very last box, right, on the stoichiometry map. You take the mass and you divide it by the density. Volume equals mass divided by density. The density will be given to you. But so you're going to get the number of grams on the stoichiometry map. That's your mass. You're going to divide that by the density, which would be given to you, and that will give you the volume, which is going to be when you're asked to find the volume of a liquid or solid. So here's what the whole thing looks like. This is kind of, might be a little confusing, but it sort of gives you all the possibilities in one shot here. So if you're given volume of a gas, you're going to start up here, and then you're going to convert down to moles, and then go through these middle boxes that are always the same, unless it's energy. That would give you moles of known. You do the mole ratio here, and then you get moles on the other side. And then depending on what you're trying to find, you could go up to volume here if that's what you want, or you could continue through to the molar mass and get grams, or if you wanted to find particles, you'd go down here. If you're given the mass, you'd start with this middle box and then continue on, and again, depending on what your answer is supposed to be, you can branch off on these other sides. And then if you're given particles, you use this bottom box, divide by 6.02 times 10 to the 23rd, which gives you moles, and then you carry on looking and follow the path to whichever answer you need. And the other differences would be if you're given moles or you're given energy, you could start in the second box. You don't need any of these boxes on this side. Okay, if you're given moles or you're given energy, you start here and you plug in the number. You're given the number of moles, you're given the energy, the number of kilojoules, you put those in here. And the difference here is to remember that if you're working with energy, one of your coefficients is going to be the number of kilojoules that's in the equation. So if you're starting with energy here, then your known coefficient is the number of kilojoules that's in the equation. If you're given moles and you're trying to find energy over here, then the coefficient that's on the top is going to be the number of kilojoules from the equation. So this is a lot to look at, but it is sort of, and then the density problems would be, again, outside this map. That's an added step at the beginning or the end, where you're either converting to grams, and then you would start here, or at the end, you would have grams, and then you need to convert to volume at the end. So those are the different possibilities, and hopefully that helps. Lets you know where you can start and where you can stop, depending on what you're given, because they're all the different variations. There you have it.